All right, welcome back, guys. I want to show you another new thing in a second, but I want to do this practice problem first, just so we're clear on what we have to do. Another one with pulleys. You can also have things that are not just hanging on a pulley. In this case, I have no friction, so mu equals 0 here. I have two ideal pulleys, which means they're frictionless and massless. I'm going to identify my positive direction by going counterclockwise, and I'm going to do a free body diagram for each of these blocks. So the first thing that I'm going to do is for the 4 kilogram block, I'm going to call that one M1. And I'm going to say M1G down, T1 up. I think this is going to be longer than that one. Common sense tells me that if I have more force on this side than that side, that this is going to win out. So that arrow should be longer. For the 1 kilogram block, switch colors. I'm going to have a much smaller weight, and I'm going to have an arrow equal to T1, but in the opposite direction. And not opposite direction as in this one's up and that one's down, but opposite direction that it would turn the pulley, so they cancel out. So remember, it's the direction the pulley turns which defines what's positive and negative. And then I'm going to have another tension going that way, and I'm saying that T1 is greater than T2 because I'm expecting everything to go that way. Then for the last one, I'm going to have a T2 equal to that T2 and greater than this weight. Because I'm saying that this is going to go up, so this arrow needs to be unbalanced, stronger than that one. And again, I'm going to go through my Fnets. For the blue one, Fnet equals M1A. I'm going to take my counterclockwise minus clockwise equals MA. So counterclockwise would be things that turn the pulley this way. And in this case, it's the weight. So it's going to be M1G minus T1 equals M1A. For the 1 kilogram block, M2, I'm going to do Fnet equals M2A. Again, I'm going to do counterclockwise minus clockwise. So this is going to be T1 minus T2 equals M2A. So this would turn the pulley counterclockwise. This one would turn it clockwise. It'd be a negative force because the arrows are opposing each other. Then for the third one, I'm going to do Fnet equals M3A. And I'm going to take T2 minus M3G, right? How did I mess this up? Oh, because I made that M1G. It should be M2G. So that makes this M3G. So I'm going to do T2 minus M3G. Erase that so it's a little bit clearer. I apologize, guys. So I'm going to have Fnet is equal to M3A, and I'm going to say T2 minus M3G is equal to M3A. And I'm going to add them together. And what's going to happen? Our tensions are internal, and they're going to cancel out. So I'm going to have M1G minus M3G is equal to M1 plus M2 plus M3 times A. And we all have the same acceleration because they're connected. Now, what's missing from when we just had a pulley? This mass is not contributing its force to the acceleration. It's balancing the normal. But we still have to accelerate it. It's part of the total mass. So I'm going to say M1G minus m3g over m1 plus m2 plus m3. And so this would be 40 minus 20 over 4 plus 1 plus 2 is 7 kilograms. And so my acceleration is going to be 20 divided by 7. So 2.9. Positive, not because it's up, not because it's down, not because it's to the right or the left, because it turns the pulley in a counterclockwise direction. And that's the way we define positives. All right, beginning at time t equals 0, a student exerts a horizontal force on a box of mass 30 kilograms, causing it to move at 1.2 meters per second towards an elevator door located 16 meters away as shown above. The coefficient of kinetic friction, mu k, between the box and the floor is 0.2. On the dot below that represents the box, draw and label the forces, not components, that act on the box as it moves at a constant speed. Constant speed is Fnet is equal to 0. So we're going to say that it is F student going one way, an equal arrow that's friction going the other, weight going down, and normal going down. So these two are equal and those two are equal. Calculate the magnitude of the horizontal force the student must exert in a box in order to keep it moving at 1.2 meters per second. Okay, so I'm going to say that I have Fnet equals 0 in each direction. I also know that friction is equal to mu times n. So this is going to be, I need to get n. So I'll do the y direction. Fnet equals 0, ups minus downs, n minus mg is equal to 0, n is equal to mg. So this is 300 newtons, 30 kilograms times 10. Now in the x direction, Fnet equals 0. It's moving at a constant speed. So I'm going to do rights minus lefts. So I'm going to say F student minus friction is equal to 0. So F student is equal to friction is equal to mu n. Mu is given to us as 0.2. And so we're going to have 0.2 times 300, which is 60 newtons, which they gave us as an answer. At 4 seconds, the elevator door is open and remain open for 5 seconds. The student immediately exerts a larger constant force on the box, and the front of the box reaches the elevator door just as it starts to close. Calculate the magnitude of the new force the student exerts. All right, so 2 parts of the problem here is we started off 16 meters, 60 meters away. We need to know how close we are when they start accelerating. So we know that they go at 1.2 meters per second. For 4 seconds. Because 16 meters is the total distance. All right, so I can get how far they went in those 4 seconds by doing, because that's 0. So I'm going to have 1.2 meters per second times 4 seconds is 4.8 meters. 16 meters minus 4.8 is going to be 11.2 meters. So now, when they accelerate, which we don't know what that is, we know that they have to get 11.2 meters, and they only have 5 seconds to get there. So I want to know what the acceleration is. So looking at this, I know that x minus x naught is equal to v naught t plus 1/2 at squared. So I can do x minus x naught minus v naught t times 2 divided by t squared. And I got 0.416 meters per second squared. All right, to get the force applied, I know that my Fnet is equal to ma, and that's going to be the force applied minus F fric is equal to ma. So the force applied needs to be equal to ma plus F fric. So we need the mass of the box 30, the acceleration, which is 0.416, and I need to add in the force of friction, which isn't going to change. So the force of friction is the same as what the student was pushing originally, and it's 60. And I got 72.5, which is close to them. All right, on the axis below, sketch the graphs of acceleration v in position t between t time equals 0 and when the box reaches the elevator. No, it actually gives us what the seconds are. All right, so as he's going along, for the first 4 seconds, velocity is just 1.2. That means my acceleration is 0. That means that my distance is, and this only goes 4.8, so I'm going to make it then my acceleration increases to 0.416. This happens immediately. So my velocity is going to increase for those 5 seconds. This should have a slope of 0.416. And then the distance that I cover, if we're accelerating, this should be a curve. If you're not sure if it looks like a curve when you sketch it, you can write down curve and point to it. Because sometimes it's hard to say whether it's straight or a curve.